Okay, in this concept, we're going to practice solving systems of equations by graphing, using the graphing method, okay? Now, a system of equations is two or more equations that are together to be solved where they would have common values between them, right? So here's an example. If I have two equations, each of them being in both x and y, right, so y equals x plus 2, and then y plus x is equal to -1. This is called a system of equations. Okay, now a system of equations can have one solution, no solutions, or an infinite number of solutions. Now, if the graphs of the system of equations intersect, then the system has a single solution. Okay, so if you have something, where, for example, you have two lines, right, and they do this is your solution, right? If the graphs of the system of equations are parallel, right, let's say you have something like this, right, you have two lines, but they're parallel. They never meet, right? Then the system is said to have no solution. Okay? If the graphs coincide, right, let's say you have, two lines, but they're on top of each other. So this is one for one equation, and then the other one is on top of it, like coincident on top of it. Then the system is said to have an infinite number of solutions. Okay? And here's what I was just showing you by drawing, right? So a single solution is an intersection. And again, this is all related to linear equations, right? Where the result is a line. When graphed, the result is a line in a linear equation. So a single solution, again, is an intersection. No solution. A no-solution scenario is where the two lines are parallel. They never meet. Okay, they extend to infinity while being parallel. Right? There's never any intersection. And an infinite amount of solutions happens when the two lines coincide with each other. Okay, they're on top of each other. So all values do satisfy both equations. Now first, let's look at an example of a system of equations having no solution. So solve the system of equations. So equation 1 is 2y equals minus 2x plus 3. Equation 2 is 2x plus 2y equals minus 9. So first we find the x and y intercepts for equation 1. And then we connect the points and graph the line on the coordinate plane. So here for equation 1 we have to find the x-intercept, we set y equal to 0, right? So we set y equal to 0, which makes this whole thing 0. This is 0, not 6. So minus 2x plus 3 equals 0, so 2x equals 3. So x equals 3/2, just like we have here. Doing the same for the y-intercept, we get, setting x equal to 0, this goes to 0, and then this becomes 2y equals 3, so y equals 3/2. Okay, this is the y-intercept. We do the same thing for the second equation, equation 2, right, to get the x and y-intercept. And then we get for x, the x-intercept is minus 9 over 2. The y-intercept is also minus 9 over 2. By graphing both of these equations, we get these two lines, right? So 0 and 3/2, this is one of the equations, and then 3/2 and 0. These are the two intercepts for one of the equations, and then we connect the line, right? And then these are the two intercepts for the other equation, okay? minus 9 halves and 0, and then 0 and minus 9 halves, and then we extend the line. Now these lines are parallel. Okay, they are parallel. They never intercept anywhere. They never meet anywhere. Okay, so this system of equations is said to have no solution. Okay, because these two lines are parallel. Let's look at another example for a system of equations that has one solution. So solve this by graphing. So equation 1 is x equals 2 plus y. Equation 2 is x plus y equals 4. So again, we go through the steps of finding the intercepts, right? So for equation 1, the x-intercept is found by setting y equal to 0, which gives us 2 for x, for the x-intercept. The y-intercept is found by setting x equal to 0, which gives us minus 2 for the y-intercept. Okay? And then we do the same for equation 2 to get the intercepts. So the y-intercept is 4, the x-intercept is 4. Okay? And then we graph both equations down here. Okay? So this is the first equation, right? These are the two intercepts, 2 and 0, and then 2 and minus 2. And then for the second equation, these are the two intercepts, 4 and 0, and 0 and 4. By graphing these two lines, we get this intersection, right, at the point 3 and 1. So this is our solution. Right? Our solution is x equals 3 and y equals 1. Okay? One solution. Okay? Let's look at yet another system of equations that has infinitely many solutions. So here's the example. So we have two equations, 3x plus 3y equals minus 9, and then y equals minus x minus 3. So again, we use the same method to find the x and y intercepts for equation 1. So for the x-intercept we have minus 3, for the y-intercept we have minus 3. We do the same thing for equation 2. X-intercept is minus 3, y-intercept is minus 3. And then we graph both equations, right? So you see that both of them have an x-intercept of minus 3, and both of them have a y-intercept of minus 3. So when we connect the two intercepts together, we basically get two lines on top of each other, right? This is my attempt at showing this as a line. So we basically get the two lines on top of each other. Okay? This is one, and the other one right on top of it. Okay? So this has infinitely many solutions. Okay? An infinite number of solutions. Because all values for both equations, all values for either equation satisfy both equations. Okay, so infinitely many solutions. Okay, now we have the exercises. So please pause the video, work on these, and come back for the solutions. Okay, let's look at the first exercise. So we have 3x equals 2y plus 1, and then 2x minus y equals minus 2. So let's use our same method of finding the intercepts, right? So 3x equals 2y plus 1. The x-intercept is x equals, so in this case we need to set y equal to 0 for the x-intercept, so this term becomes 0. So 3x equals 1, so the x-intercept is 1/3. 1/3. The y-intercept, right? For the y-intercept, we need to set x equal to 0, so this becomes 0. So 2y plus 1 equals 0, so y equals minus 1/2, right? And moving on to the next equation, we have 2x minus y equals minus 2. The x-intercept is, we set y equal to 0, so 2x equals -2, so x is equal to -1. Okay, the y-intercept, y equals, so here we set x equal to 0, so we have minus y equals -2, so y equals 2. Okay, graphing this on the coordinate plane, we have, oops, this looks bad. Yeah, we have, so x, so we have 1, 2, 1, 2. Again, you know, this is a rough sketch. Obviously, it would be much more accurate with a ruler or on graph paper, but you know, just this is an attempt to make it seem accurate on a hand sketch. So here, 1, 2, -3. Okay, so x is 1/3, so this is somewhere here, right? Y is minus 1/2, which is here. And then these two are connected to give me a long line. Okay, x is -1 is here. Y is 2, which is here. And these two actually, well, you know, this should be like this. This should be like this. Right? So this is really going to be parallel. Okay, these two are going to be parallel. Okay, so this system of equations will have no solutions. Okay, because these will be parallel. Moving on to the next system of equations, x minus y equals 0, minus x plus y equals 1. So again, the goal is to find the initial goal is to find the intercepts. So the x-intercept is found by setting y equal to 0. So with y 0, we get x equals 0. The y-intercept is found by setting x equal to 0, so minus y equals 0, so y equals 0. Okay? Now for the second equation, minus x plus y equals 1, we have the x-intercept as, so we set y equal to 0, we have minus x equals 1, so we have x equals -1. Okay, and then we have the y-intercept, right, found by setting x equal to 0, so y is equal to, I'm sorry, this is equal to, yeah. So y is equal to 1. Okay, graphing these on the coordinate plane, we get, so the first line has x-intercept at 0 and y-intercept at 0. So that's interesting. We have a single point. So how would you draw this? Well, a very quick way to figure out what this looks like is to go back to the actual equation. This is really the equation of x equals y, right? So it's just the line x equals y, or y equals x, right? This is y equals x. So y equals x is the line that looks like this, right? Every y value has the same x value. So 1 and 1, 2 and 2, 3 and 3, etc. Okay? Graphing the second equation, we get these two intercepts. So x is -1, right? And y is, the y-intercept is 1, right? So we get something that looks like this. So again, this is similar to y equals x, but you know, with like a translation, right? So these are actually parallel. These two lines are going to be parallel. So here there are no solutions as well. Okay, and for the last one, we have y equals 2x plus 8 and 3x minus 3y equals 9. So what we're going to have is, if we find the intercepts, I'll leave the intercept work to you, but I'll summarize by saying the intercept here is going to be, for x, we're going to have x equals, so minus 8 over 2, which is minus 4. Okay, and we'll have y, the y-intercept will be y equals, actually, yeah, so for y-intercept, yeah, y equals 8. Okay, so these are the intercepts for this one. For this one, we'll have an x-intercept of x equals 3, and then a y-intercept of y equals -3. Okay, so if we attempt to graph these, right, on the coordinate plane, so here the x-intercept is -4, so, you know, 1, 2, 3, 4, -4, right? This is the x-intercept. The y-intercept is 8, so it's like all the way up here, right? Right? And so this axis obviously extends up here. For the second equation, the x-intercept is 1, 2, 3, right? And for y, it is 1, 2, -3. Right? So now we have this line. Well, I'm kind of running out of space here, but they do intersect somewhere down there. And by certainly something like this would certainly need graph paper or, you know, a good ruler. When they intersect down there, if you've graphed it to scale appropriately, you will get an intersection at x equals -11 and y equals -14. Okay, so this is the one solution. Okay, one solution. Okay, and obviously, again, the graphing method is one of the methods of solving a system of equations. We will look at the other methods in the following concepts, but for the graphing method, you've seen how you could use it to find the systems that have no solutions or the single solution, and we've talked about the systems with infinitely many solutions. Okay, this is it for this concept. See you in the next video.